Alright, in this video we are going to be addressing negative numbers. If you have not watched the last video on subtraction, I highly recommend doing so because it does introduce some of what we're working with today. To begin with, we have to realize a negative number is simply leftward movement on the number line. And that also means that a negative number by itself exists to the left of 0 on the number line. So as you can see, we have extended our number line to include negative numbers to the left. We're still counting by units of 1, but we're now extending our number line to move to the left of 0. So we move 1 unit to get to negative 1, another to get to negative 2, and so on. We've already discussed in the previous video that 6 minus 3 is the same thing as 6 and negative 3. Both of these expressions represent moving to the right by 6 and then moving to the left by 3. This is also a good opportunity to point out that negative 6, by definition, is the opposite of 6. That when we add 6, or move to the right 6, and then take away 6, or move to the left 6, we have in effect canceled both of those things out and returned back to 0. When we say negative 7, technically what we mean is starting at 0, move to the left 7. But it's unnecessary to write the 0, so we leave it as just negative 7. And this is the same thing as 5 technically being 0 plus 5, or 0 and then to the right 5. The set of numbers that we're looking at on this number line that are moving in units of 1 either to the left or right of the number line are called integers. As you can see, when we have 5 minus 8 or 5 plus negative 8, we are moving to the right 5 and then to the left 8. As a consequence, we do wind up with a negative number as our solution, which is perfectly fine. That just means that the solution is 3 to the left of 0 on our number line. We can also begin by moving to the left by saying negative 5, or move to the left 5, and then move to the right 4, or plus 4, which results with the solution of negative 1. I'd encourage you to pause your screen and work through these, just to simply work by moving back and forth on the number line. Now, there is a strange situation in which we will encounter 5 minus negative 2. And we're going to talk about what this means algebraically, and then we're also going to do a demonstration of it on the number line. You may already recognize or remember that 5 minus negative 2 actually means 5 plus 2. Some teachers will say when you see the two negatives, make a positive, which is great. That's not wrong. We need to understand why. We need to have some actual explanation so it's not just sort of an empty procedure. To begin with, we're going to prove that minus negative x, in fact, equals positive x. And in doing so, we will then be able to demonstrate that minus any number is the same thing as positive that number. Therefore, minus negative 2 is positive 2, or plus 2. Since we know by our definition of a negative number, when we say minus negative x, we actually mean 0 minus negative x, which equals x. We can use the inverse property of subtraction, which was introduced in the last video, to say, okay, if a plus b is c, then c minus b is a. Well, let's look at this. C, which is 0, minus b, which is negative x, equals x. That's what this statement right up here says. Then a, which is x, plus negative x must equal 0. Well, based on our identity property of subtraction, that a negative and a positive cancel each other out, we know that x plus negative x is the same thing as x minus x, which equals 0. Now we can plug in these numbers to prove that 5 minus negative 2 is the same thing as 5 plus 2. So we're going to start off by making the statement that 5 minus negative 2 equals something. In this example, we say m. We can use that inverse property of subtraction to say that then m, or c, plus b, which is negative 2, must equal a, which is 5. Plus negative 2 is the same thing as minus 2, therefore m minus 2 equals 5. And we can use the inverse property of subtraction again to say, well, if m minus 2 is 5, then 5 plus 2 must be m. 5 plus 2 equals 7. What we've demonstrated here is that 5 minus negative 2 is the same thing as 5 plus 2. Conceptually on a number line, what we're talking about, when we say minus negative 2, that literally can be translated into x is the value, our solution is the value, if you take away the act of moving to the left by 2. So if we're at 5 and then we say, hey, remember when we took away 2? Let's undo that. We say, okay, well then it must be 2 higher than where we left off. We're taking away the act of moving to the left 2, which means we must be to the right 2 of 5, or at 7. I'd encourage you to pause your screen and look through and see, once again, this is just another set of numbers that demonstrate that 6 minus negative 3 is the same thing as 6 plus 3. And a few problems to work out on your own. A common example of negative numbers is the concept of debt. If you have $12 and you owe somebody $8, how much money do you have? Well, that'd be 5 and negative 8. $12 positive, and then a debt of 8. Here we have $7 and we owe someone $9, so we actually are in debt $2 still. We pay off our $7, 7 plus negative 9, we pay off 7, but then we have to move to the left on the number line 2 more, and we're left with negative 2, or $2 of debt. Jason has $19 and owes Melissa $12, and he owes Michael $8. How much money does he actually have? You can work through that yourself. One other example of negative numbers has to do with atoms. And in 8th grade science, you're going to be dealing with atoms. So this is very closely related to what you're going to be doing with Miss Woodard. All atoms, which are incredibly teeny things, as a matter of fact, this huge number is the number of atoms in a single human cell. So that just hopefully gives context of how teeny an atom actually is. All atoms are made up of electrons and protons. Each electron has a negative charge of 1, and each proton has a positive charge of 1. So we can take some examples. If a lithium atom has 3 protons and 5 electrons, what is its total charge? Well, that's 3 positive and 5 negative. That means its total charge must be negative 2. And I'll let you take a look at these other 2 problems to see how they relate. This has been an introduction to negative numbers. We're going to work back on subtraction in later videos, and then once we get through multiplication and division and fractions, we'll reach a point where we're going back and forth between positive and negative numbers pretty freely, which is a very important thing to do in 8th grade math. Thank you so much.